Alright, linear programming is a technique we use to optimize a function. We use it to either minimize something or maximize something. And the first thing you do is write the objective function. That's the thing you're trying to either minimize or maximize. Then you're going to write constraints. And these are inequalities that give you your shaded area. And when you graph the constraints, you get the shaded area. And the vertices are the corners of the shaded area, and those corners are what you plug in to the objective function. And then you evaluate the objective function for each vertex, and you pick whichever is the highest or lowest depending on what you're asking. So that may not make a lot of sense yet, but let's do an example. Alright, so we're going to find the maximum value of z equals 2x plus y. So guys, this is our objective function, and we want to maximize that. So those are two things to keep in mind, okay? All right, now here are constraints. We have 4 of them. We have x greater than or equal to 1, x less than or equal to 4, x plus y is less than or equal to 5, and y is greater than or equal to 0. So I'm going to graph those constraints. So x greater than or equal to 1. Okay, that means I'm going to have a solid vertical line passing through the x-axis at 1, and I want to shade everything to the right of 1. So that's everything over here, all right? All right, x is less than or equal to 4. I'm going to do that in red. So that's going to be a vertical line passing through the x-axis at 4, and x is less than that, so I'm going to shade everything to the left. Okay, x plus y is less than or equal to 5. I'm going to solve that for y. So y is less than or equal to negative x plus 5. So I'm going to go to 5 on the y-axis, and my slope is negative 1. So I'm going to go down 1 over 1, down 1 over 1. So it's going down like this. Okay, hang on a minute. Okay, I regraphed it because you have to be really careful on your graphing, all right? So this is intersecting at this point right here, and it's intersecting at that point right there. Okay, so y is less than or equal to negative x plus 5, so we want everything below that line. And finally, y is greater than or equal to 0 means it's everything above the x-axis. So here is our final shaded area. It's a trapezoid. Can everybody see that? All right, now the next thing to do is to locate the vertices of this shaded area, the corners. So this is at 4, 1. This one down here is at 4, 0. This one right here is at 1, 0. And this one here is at 1, 4. Okay? And the way you can get that if you can't read it directly off the graph is you can take your x coordinate for this blue line, which is 1, plug it in right there, and y will equal negative 1 plus 5, which is 4. So that's how I get that point right there. And then this point right here, I can plug in my x coordinate from the red line, which is 4, and y will equal negative 4 plus 5, which is 1. So that's where these points come from. Okay, so what I'm going to do now is set up a table, x, y, and z, and I'm going to bring in my objective function, which you remember is z equals 2x plus y. And I'm going to plug the coordinates of these vertices into that objective function and see what I get out for z. So let's do 1, 0. When x is 1 and y is 0, I get 2 times 1 plus 0, which is 2. Let's plug in 1, 4. So I'm going to plug in 1 for x, 4 for y. I'm going to get 2 times 1, which is 2, plus 4 gives me 6. Let's plug in 4, 1. So when x is 4 and y is 1, z is going to be 2 times 4, which is 8, plus 1, which is 9. And finally, we're going to plug in 4, 0, and that says that z will be 2 times 4, which is 8, plus 0, which is 8. And now all we need to do, since we want to maximize this, we pick the highest value of z. And so that's our maximum value subject to these constraints. All right, so this was a real simple example because I gave you the objective function, and I gave you the constraints. In real life, you're going to have to figure out the objective function yourself and the constraints based on the problem situation. But this is the basic process. If you can do this, now you know how to do linear programming.